In this lesson, we're going to talk about systems of equations, and specifically, we're going to be talking about how to solve a system of equations by using the method called graphing. So let's first talk about what a system of equations is. What it is a collection of two or more equations with the same set of unknowns. And the goal is to find out what the values are for each of those unknowns. And by figuring them out, we'll be able to figure out that each unknown will satisfy each and every one of the equations in the system. So, during this unit, we're going to focus on systems of equations with two equations, and we're actually going to touch on just a little bit systems of equations with three. So let's go ahead and just kind of go over some terminology before we get into graphing. So the biggest thing to know, and probably the most important thing, is the idea of a solution to a system. What this is it's an intersection of two equations. So I have three examples here in my table of three different types of graphs that you could have representing two different linear equations. So if we look at the one in blue first, you can see that I have just two lines and they intersect at one specific location. That specific location where they intersect, that point, that is called the solution to the system. So when you're dealing with two lines that intersect, and they don't necessarily have to be perpendicular, they just need to intersect at one point. What we say in this case is that we only have one solution. There's only one intersection point. We also call this type of graph independent and consistent. So let's talk about that terminology, what that means. First, let's talk about consistent and inconsistent. So the best way to look at it is this. If you have a consistent system, there is a solution. So anytime that you're solving and you end up with a solution, it's consistent. And then likewise, if you don't have an intersection point, that means there is no solution at all, and that means that it is inconsistent. And let's go ahead and talk about dependent and independent. And back up in the definition for consistent, you'll see that I added there that consistent equations or systems, they can be either independent or dependent, where inconsistent systems cannot be independent or dependent. And you'll see that as we continue to talk about these. So dependent, what does that mean? So dependent means that all points that work in one of the equations also work in other equations. And then independent means that there is exactly one solution, and that's it. So going back up to, there we go. Going back up to our graphs here, you're going to be able to see it a little bit better here. So we just talked about whenever we have one solution, so when you have those two intersecting lines, it is independent, meaning that it has just one solution. That's it, exactly one. There's no more than that. And then it means consistent, that yes, it has a solution. So now let's look to the green area. So right now it looks like there's only one line represented there, but actually it's one line on top of the other. So the system is actually two of the same exact equations. And the way you might see that in this unit is that you might have two equations that are the same in slope-intercept form, but they may look different because one may be in standard form and one may be in slope-intercept form, and until you transfer them into the same form, they look a little different. So you'll always have to put them in the same form to identify that they're the same. So when we're looking at these two lines on top of one another, we're looking for how many solutions are there. Well, again, a solution is the intersection of two lines or two equations. And so in our case, you can see that there's an infinite number of intersection points between these two lines. And you can see that I'm representing by these little dots. And I know that's not an infinite number of dots, but you can imagine that there are just hundreds and hundreds of intersection points along those two lines. So that gives us a solution of infinitely many solutions. So when we talk about the terminology dependent and independent, we have to kind of think, okay, well, consistent and inconsistent. Remember, do we have a solution? Yes, we do, and we have many. That gives us our consistency. Now, when it comes to, is it independent or dependent? Well, that comes in and we have to ask ourselves, do we have exactly one solution or do we have many? So in this case, obviously we can see that we have many, and which causes it to be dependent. Okay, now for the very last type of system that we are going to encounter, and that is two lines that are parallel to each other. And these are the only three different scenarios that you could possibly have. There's nothing else. If you kind of just think about, moving the lines around in different ways, these are the three different options that you can have with two equations on a coordinate grid. So looking at these two parallel lines, we learned in Unit 5 that two parallel lines have the same slope. So we have two lines that, doesn't matter what the y-intercepts are, but they have the same slope. So if we kind of talk about the idea of how many solutions do we have, well, we don't have any intersecting points because we know that parallel lines don't intersect. And therefore, there are no solutions to this system. So you can kind of think about that as a special case because that's kind of the way that that's the bucket that we put no solution in the past. So it's kind of like that. And then when it comes to the terminology, well, if we talk about consistent and inconsistent, automatically we know that we don't have a solution, so it has to be inconsistent. And because it's inconsistent, it cannot be neither dependent nor independent. So we just leave it as just plain old inconsistent. So we'll be referring back to this nice chart here, but I want to go ahead and jump into our first method of solving a system of linear equations. And I find this method to be the most familiar, and it's a great way to start the unit because we're already used to graphing linear equations. So all we're doing is just adding one more onto the coordinate plane. So let's look at the first system. You can see that this is my system of equations. I have two equations. I'm just going to go ahead and graph them. So if I graph x equals 4, x is a vertical line. So we're going to have a vertical line on 4. Sorry that my lines aren't super straight here. And so that's going to be my first equation. And then my second equation, I'm going to go ahead and graph that. My y-intercept is -4, and then I'm going to go up 1, and I'm going to run 2, and I'm just going to continue that pattern. And I'm going to go ahead and draw my line, and I just graphed my system of equations. So now let's talk about what the solution is. The solution, again, to the system is where it intersects. So we want the coordinate point that is the intersection point. So in our case, it's going to be x is 4 and y is -2. Okay, so what does that actually mean when it comes to the system of equations? So this is my solution. So not only is that where the two lines intersect on my coordinate plane, but let's take it back up to the two equations. Let's substitute x in for all the x's and y's in for the y's to show you that it satisfies both of these equations. So for the first one, x equals 4, if I substitute what I got for x down here, you can see that 4 is going to equal to 4, which satisfies this equation. Okay, let's work on the other one. Y, that's going to be -2 equals 1/2 times my x, which is 4, minus 4. So if I go ahead and just kind of quickly simplify that down, you can see that I have -2 is equal to -2. So it satisfies the second equation as well. So this coordinate point down here, my solution, is the only coordinate that will satisfy both of those linear equations. Okay, so let's talk about some vocabulary now. Consistent versus inconsistent. Well, consistent means that we have a solution here, which we obviously do. So I'm going to say consistent. And the difference between independent and dependent is the idea of having one solution, exactly one, or more than one. So in our case here, we have exactly one solution. So we're going to have an independent and consistent system of equations. Okay, let's try another system of equations. All right. So you'll notice that my new system here has, they're both in slope-intercept form, which is great. So I'm going to start with my top one. I'm just going to go ahead and graph that. So I have my y-intercept of -2, and then I have a slope of -2. And just like in our graphing unit in Unit 4, we want to make sure that we put all of our coordinate points, and when we draw our line, we extend the arrows from the top to the bottom all the way across the coordinate plane, just for you know, neatness, and it just looks really good when you're finished. And organization is really important here. And then the other one, my y-intercept is 3, and then I'm going to go down by 1 and cross by 3. Keep going here. All right. Draw my nice line. Hopefully your lines are a little straighter than mine. Okay. So we have one solution here. We can see the solution is right about there. So my solution looks like, what is that? -3, +4. And if you want to, you can check it back up in those two equations just to double check yourself. But you don't have to do that. It's just, you know, a good way to check yourself. And again, we have a consistent system, and this one just happens to be independent. Okay, so that's basically the gist of how to graph a system of linear equations, but I am going to show you some more examples just to kind of show you some different things that you might encounter. Okay, so here's the first thing. You'll see that I have a system of equations here, but you'll also see that it's not in slope-intercept form. And it could be in standard form, it can be in point-slope form, and it can be in no form at all. So in our case here, we have two equations that are not in any form at all. So I have to put them into a specific form. And I'm going to go ahead and put them into slope-intercept form because that's the best form to graph, to be honest with you. So if you want to put it in standard form, if you want to put it in point-slope form and graph that way, that's fine too. But I usually like to go with my slope-intercept form. So I'm just going to kind of move some things around with my first one. I'm actually going to flip this whole thing around to get my y on the left. And then I'm going to go ahead and I'm going to divide both sides by 2. And that will give me y is equal to 1/2 x minus 3. Okay, so that's going to be my first equation. I'm going to go ahead and graph that real quick. Okay, draw my nice line. My arrows. Okay, and now I'm going to go ahead and work on my other one. I'm going to rewrite it first. I'm going to move some things around. And I'm going to go ahead and divide by -2. All right, so I have y is equal to, I'm sorry, I'm running out of room here, 1/2 x minus 2. All right, great. So let's go ahead and graph this one now. Probably noticed that our slopes are the same, huh? So let's go ahead and graph that. All right. So yes, we do have two parallel lines. And two parallel lines, you can identify that right off of the equations, or once you graph it, you'll be able to see that as well. And so your solution in our case is going to be, well, there's no solution. All right, and if we're talking about consistency, there is no consistency here. There is no solution, so it's inconsistent, which means that if you have an inconsistent solution, you can't be either independent or dependent. It doesn't work. All right, let's go ahead and look at another one here. Again, I'm not in any particular form, so I have to take a second and I have to actually go and put it into slope-intercept form. So I can do that quickly. Luckily, we did this in Unit 4 and 5, so it should be real familiar to us and almost second nature. Divide by 3. Okay, and I'm going to have y equals -6x plus 4. Okay, so that's my first equation. Let's go ahead and graph that. All right, it looks like I'm only going to get 2 points on this one. Okay, and then I'm going to go ahead and do my other one. Y minus 4 equals negative 6x. I'm going to go ahead and transfer that a little bit. I'm just going to add 4 to both sides. Okay, so look what we ended up with here. We ended up with two equations that are identical to one another. And you couldn't really tell that from the beginning. You had to transfer it into slope-intercept form first. So now that we landed with two equations that are the same, I really just have to draw one line, just like what I did here. But now when I write my solution, I'm going to write that there are infinitely many solutions. And if you don't want to write out infinitely many solutions, I am happy to write just infinitely many solutions as IMS. That's perfectly fine. So if we talk about consistency, well, there is a solution and there's more than one, so I'm going to say that this is consistent. And is it independent or dependent? Well, independent means that there's one solution. Dependent means that there's many solutions. So this is going to be a consistent and dependent system of equations. All right, let's take a look at one more. Now we're going to go the opposite direction. Now we're going to go, now we have a system and we want to figure out what are the two equations that are being represented here. And this is fairly simple to do because we're just looking at a graph and figuring out what are the equations represented. So I'm going to go ahead and I'm going to look at the first one and I'm going to look at this line that I'm putting a star next to. So if I go ahead and do this, I'm going to say, all right, well, y is equal to, I have to figure out what my slope is first. So it looks like my slope is going to be a 2, and then 2, so 2x, and then my y-intercept is 2. And then if I hop over to the other one, it looks like I have a negative slope here. So y is equal to negative 1/2 x minus 3. And so now that I've written both of those, that is my system of equations. And you know, I may ask a question like, place the system of equations in standard form. And you just have to take those two equations and transfer them. And I know I didn't ask in this question, but you can see that this is going to have one solution. So this is a consistent system, and it is also independent. All right, and our last one here, I'm going to go ahead and start with the one up in the corner. This line right here, it's a horizontal line, so that's going to give me an equation of y equals 4 because it's laying on 4. And then if I move to my other one, let's see, it looks like y is equal to, it looks like negative 3x plus 1. So there's my system there. And again, I have one solution in this case here. So this is a consistent system, and it is also independent. Okay, that is the end of the lesson on graphing systems of equations. And we will be talking about the other methods on how to solve it. But this is just one of the methods on how to solve a system.